Hello there, my name's Vince from My Mate Vince, and in this video today we're going to be looking at this faulty, ridiculously large monitor. Look how wide the thing is. I've never seen anything like it in my life. It's got a lovely curve to it and it is absolutely huge. So it all looks very high quality, but it's not working. You can see that the backlight's on, but there's nothing happening. Yet it is recognised as a screen. So when I plug it in from here to here, it does recognise itself as a screen. So you can see there, I've got that there. When I plug it in here, it will go to the screen, the second screen. Well, this will become the second screen, this will become the first screen, but it's not actually displaying anything. So although the backlight's on, there's nobody actually home. So this monitor, I believe, is a couple of £1,000, and it's got a backstory to it. This was given to me by my friend Brian, and he said he had a large monitor. He brought it round in his van. When I seen it, I thought it was a bumper. That's how big it was in the back of the van, because it's white at the back. I didn't dream he'd bring something round that was so large. I've never seen anything like it before. But the backstory is that it was owned by a Turkish guy who made his millions on cryptocurrency. So he had a normal life. I don't think he had much money at all. And then basically, I'm just wondering why we haven't got the blue screen now. Right, that's off. Let's turn it on. There we go, blue screen again. Yeah, basically, he didn't have much money, and then he ended up, in the space of a few years, making millions from cryptocurrency, and he is now retired in Turkey and bought himself various big mansions. And this was the screen that he made his money with. So you never know, it might give me some good fortune if I can fix the thing. He left the country, and it was working fine. And now it was in a flat. Now Brian's taken the stuff out of the flat because they're friends, and it's not working anymore. And looking online, this is quite a common problem where this goes into storage, and when you start it up again, it doesn't work. Quite a few people have fixed it by ripping a thermistor off the board. What's that about? So I think it's going to be quite interesting. Let's take the back off it, and then let's get the FLIR cam on. See, is the thermistor circuit part of some circuit where maybe a capacitor's failed, and by taking off the thermistor, it then just comes to life? But what's the thermistor doing in there? Not too sure, but it should be an interesting one. But it's definitely recognising here. So the main brain of it must be okay. For some reason, it's just not displaying anything. It's just displaying a backlight, which gives you this kind of blue hue here. So let's get the back off, get the FLIR cam out, and let's see if it gives us any idea about what the fault might be. Apparently it has an LED light at the back as well, which is supposed to shine out. It's not doing that either. So we're unplugged from the mains, and the HDMI cable is out. Let's pop the back cover off. There's two little indentations, one this side, one this side. So I'm going to get some pry tools, start prying. Hopefully I'm not going to damage the screen, but Brian's well aware that I may break it in the process of trying to fix it, and that's a risk he's willing to take. Okay, I've got a selection of pry tools here. The problem I've got is I need to start underneath. So I think I'm going to have to lay this monitor down flat. If it was a flat monitor, I wouldn't be bothered, but there's going to be an awful lot of weight on the corners of the screen because it's curved. So what I might do is I might get a couple of duvets down or something and lay them on the floor. That might take more, it might spread the weight a little bit more than having all the weight on the corners, especially when I'm prying to try to get the back off. Right, I've got a seat cushion there, and I'm going to put down some massive cushions. Actually, one will be enough. And I'm hoping that might spread the weight. Now this could be over before I even begin if I put this down, and it would crack. Please don't crack. So heavy. Here we go. Okay, I think that's probably better than that and putting it flat down straight on the floor. Okay, now I want to remove this stand because it's in my way. There's a little kind of ring in here that you have to undo, and then it separates like so. And now I've got two more bits that kind of separate, and I've got 4 screws in there, so I'm going to undo those 4 screws. I think they might be held in there, so I think you just have to loosen them. Yeah, they only come out so far, don't go anymore. There we go. Yes, we're out. And it just clips in from the top here. There's a little little home that sits into. We're going to start unclipping from these parts here. There's one part down here and there's another part just down here. Right, this is where it might go terribly wrong. Okay, so it wants to come up from there. And then we have various clips at the bottom here. Actually, so far so good. There was a teardown video online and the guy said to stay away from the corner bits. So there's like little connectors, I think, that go down to the screen, and it's just on these little corner bits here. So from here to here and also up here, stay away from there. It's very hard because the problem is you're only going to have so many pry tools, and already I'm running out. It's not wanting to come off in this middle section here, so it's kind of loose on either edge, but it's not doing anything from here. It just seems to want to click straight back into place again. Right, this one by the power button doesn't want to come undone at all. There we go. Right, so that I think is the bottom undone. Yeah, that seems to be all the way across. Right, now let's move to this edge here because it's near the camera. So pry it from here. Oh, there we go. Wow. Okay. Yeah, that wasn't too bad at all. I'm going to do the same over the other side. That's satisfying. Now let's go across the top. Oh, hello. So satisfying. Right, I'm slightly confused because it feels like, oh yes, I'm out. I'm done, I think. I was going to say, it feels like I've done it everywhere. Hallelujah! Amazing!
And do you know what else is amazing? The sponsor of today's video. That's right, my mate Vince, partner of the year. I'd like to think it's just for me, but I'm sure there's quite a few of these floating around. But anyway, I'm taking it. The sponsor of today's video is, of course, PCBWay.
PCBWay is your one-stop solution for all things PCB fabrication and assembly. From rapid prototyping to full-scale production, PCBWay delivers top-quality products. So whether you're a seasoned engineer or a hobbyist just starting out, PCBWay's user-friendly interface makes ordering your own custom PCBs very easy. And PCBWay do a variety of different services, including but not limited to assembling your PCBs, CNC machining, 3D printing, sheet metal fabrication, and injection moulding. So when you're ready to take your designs to the next level, look no further than PCBWay and bring your ideas to life.
So a massive thank you to PCBWay for sponsoring the My Mate Vince channel and sending me nice heavy little awards like this. It makes me feel wanted. Anyway, let's get back to this monitor.
Right, I can see a bit of breakage here and here. So that's 2 clips gone, but apart from that, not too bad. Now obviously I'm unplugged, so there's no mains going into this anymore. I've still got to be careful in this area here because the mains capacitors might still have voltage in them. So yeah, there we have it. We've got a nice bit of dust around the place. Brilliant. You can see why I thought it was like a bumper. It's absolutely huge, this thing. Right now, so what do we have? We've got a board here, which looks like it's just all for the lights, the LEDs. This must be the power board. So I presume it's this board that we need to take the cover off. And then, I don't know, get the FLIR cam on, plug it in, and see if we have anything. And these are like the gold things down here that the screen or something connects to. There was another video out there where they heat up the corners of the screens and it starts working again. And that's, of course, there's some board under here that might be faulty. And maybe applying heat makes it work. I think we need to look at this here because, mind you, hold on. There's going to be, what's this? Driver. There's a board under here as well. Maybe I need to go to this board. Maybe this is like the T-con board with the thermistor on. Let's get my screws out. Oh, there's a screw missing here. I wonder, has somebody been in here already? There's a screw missing just there. Anyway, I'm going to undo this to begin with and see what's happening. As far as I can see, everything is connected. Let's unplug that. Okay. So it's got all this wire along the top here, and the back case clips into the wire. Now, what is keeping you down? Is it just thermal pads? Whoa! I've never seen a thermal pad so big. We also have a hair in here. Crypto Millionaire hair. Look at that thermal pad. Holy moly. Whoa! That's insane. Oh well. Okay. So the thermistor they're talking about is this tiny little one in here. I'll zoom in and show you that now. So I'm wondering whether or not by taking that out you're stopping a certain circuit from working, which just so happens to get it fired up and working. But what is it doing there? So it is apparently this one here. It is this little fella here, I believe. Right, first things first, let's get an ohm reading off it, and then I think we need to plug this back in, keep our hands well clear, and then see with the FLIR cam if something's getting warm. Right, so we're just on resistance. See if we're reading anything. Right, 3,135 ohms, so 3.135 kiloohms. Okay, so it is reading something. Let's power it up and with the FLIR cam see what's happening here. I wonder, does this have anything else on it, or is it just purely for the LED ring? I suppose what we could do is, nothing's going to short there anyway, so we could plug this back in and just have it out of the way. And that way then everything is exactly like it was, apart from the back cover is removed. Okay, FLIR cam will be on in a minute. Let's plug this in here. I've got the monitor plugged in. I can see it's all lit up here, backlights. So I'm just going to put my head under, make sure it's not working. No, it's still blue screen as far as I can see, which is good. Now, FLIR cam time. Please show something. Okay, right, well, there's various hotspots on the board. The problem is that they're just chips getting warm, aren't they? They're just the chips that are getting warm. So I've got to be careful because the heatsink's not on here at the moment. Now, why we're taking the thermistor off affected? There's no heat up by the thermistor at all. You can see my finger. You might not be able to. But the only thing, there you go, the only thing getting warm are the chips. Okay, I don't think the FLIR cam is going to show anything in this instance. I think because so many people have fixed it by ripping the thermistor off, let's take this board out, bring it over to the blue mat. And let's see, I can see it goes to a via on one side and it goes to this chip on another side. Let's see after the via where it goes to. It may give us an indication the thermistor might not be faulty at all. It might be just cutting a circuit which goes off, and that circuit might be faulty. So I'm going to turn all this off and take the board out. Right, so you just pinch these to take them off. That's those two gone. Now these I presume you lift up. Do you? Yes, you do. I'm using both hands because it might be too much strain in the middle there. They're massive. Okay, so they're all undone. So we can take this board out now. We've got a little screw here and here. See, if that thermistor goes directly to one of the pins down here, maybe it's this bottom board which is faulty, and maybe that's why when people are heating up the corners of this device, it starts working. Basically, I don't want to just heat up the corners because then it might start working and we don't know what the problem is. I would like, and also the fault's going to come back apparently when you do that. I would like to find out, if possible, what is wrong with this. Right, it looks like it's held in again. I can't see any screws. I wonder is there a thermal pad on the other side? Can't see any more screws. Wow. God, it's well and truly stuck. There we go. Okay, yet another big thermal pad there. Well, unfortunately that's a hard board to trace because they painted one side of it. So I might not even be able to trace down from these thermistors down. But I'll see. Let's bring it over to the mat and see what's going on. I think I am going to... Shall I leave that on? I can leave that on for the time being. Okay, first of all, thermistors. Well, we've got two types, NTC and PTC. I don't know what this one is. On an NTC, the resistance decreases as the temperature increases. So as this board gets hotter, the resistance will decrease. And on a PTC, the resistance increases as the temperature increases. So as the board gets hotter, we have more resistance here. I don't know which this one is, but when we take it off, it means then we've got complete resistance, haven't we? Like loads and loads and loads of resistance because the signal can't get through anymore. So I don't know why that would make it work. But anyway, let's see. Oh, it's stuck again. Ah, that thermal pad's sticky. So we are here and it's down as a THA1 and then we have two resistors next to it and that's connected to those two resistors. So let's have a look. I'm just going to go on continuity for a moment. So that's connected to there and there. And that goes to a via there. Where does this one go to? Oh, so that's connected here and that goes back round. Around to there. This pad's a bit of a pain because I can't move the board around very easily. So that's the ground. And this, the top of the thermistor, goes around here to here. No, it doesn't. Sorry. Where does it go? To here. Then it goes into the chip here. So it goes into this chip. RT6949B. Okay, so by taking it off, The chip can no longer get a signal. Let's see where it goes to. So there's a wire here. So there's a second wire along. Second wire along, it goes to here. Where do you go to after that? I can't see at all. So there's going to be a multi-layer board and it's going to go somewhere else. I'll tell you what we'll do. Let's zoom out. Let's see if we can find out by moving around the place where it is. So this will beep. So we're going to go on this side here. This would be handy now if I had a load of fine stranded copper and I could just kind of brush it around the place like a brush of fine stranded copper, and then you would hold that onto it and it would pick it up a lot quicker. Interestingly, what are the odds of that? Seriously? I haven't... Oh, is it going to ground? Hold on. What are the odds of that? It's going down to here. I found it straight away. That's crazy. So with the outer pin and the outer pin, I wonder, is it coming up anywhere else? I can't believe on the very first tap I found that. Somebody's going to say that that's been faked, but although there is videos of people saying they've removed the thermistor and people heating it up, I haven't actually seen anybody fault find the board from what I could see, but I didn't spend a huge amount of time researching. Oh, oh, ah, is that some weird MOSFET-y thing? And that does look like a full short, because if I bring my meter in, and let's just go to resistance, on here we have 2.9 ohms, and on here same, and the leads, yeah, so you can see it's a full short. Right, let's zoom in and see what this is. Maybe this is the thing at fault. Right, it's this thing here, and it says on it Win Bond. Win Bond, is that memory? Do you reckon that's some sort of BIOS chip? Apologies for the state of my fingernails. I've been doing a bit of work on my wife's car. Talking about cars, the Rolls-Royce has now gone. I got rid of it. I sold it for peanuts, literally peanuts. I sold it as spares or repair because it had quite a few things wrong with it. So the straw that broke the camel's back was when the anti-lock braking light came on. And I just thought to myself, I've already invested enough time in this car. So yeah, I sold it off as just spares or repair. Do you know what I'm seeing? I'm seeing a load off. Is this flux? Hold on a minute. This board is covered. Wait a minute, is it anywhere else? Yeah. Strange. Did they not clean the board afterwards, or has this suffered some sort of suffered something? Okay. Do you know what? The very fact it starts working when people put a hairdryer on it, I wonder, is it making this flux a little bit more liquid or something, and then causing whatever the issue is to disappear until this goes hard again? This doesn't look quite right to me. Is that another Winbond? That's another Winbond chip. Let me just see if that's coming up. And hold on, is that chip the same? So we have a Samsung chip there. Oh, Samsung display. And what we got here? Samsung display. So would this be for a left and a right hand side of the screen or something? Let me just see if that's coming up. I wonder, is there another thermistor for the other side of the screen possibly? Because there's two connectors down here. So, 1 second. I wonder if I think I'm just going to clean the flux up. It's coming up here as well. I wonder whether the BIOS is playing up because of all the flux everywhere. I am going to get some isopropyl alcohol. I'm going to give it a right good clean up and then put it back in and see if it starts working. Ta-da! The wonder stuff. 99.9%. Now, do you know, actually thinking about it, the thermal pad's on the back here, isn't it? So what I'm seeing here is kind of oils from the thermal pad. So I'm sure it's not going to be anything, but just in case, I wonder if we do have any resistance if I go into a particularly greasy bit. So it looks very greasy around here. Let's see if we've got anything. No. No, I don't think it's going to do anything. I just want to give it a clean because it doesn't look very nice. I think we're going to have to investigate what's going down here. I think the thermistor is just cutting that part of the circuit to make it work. But what is it there for? I presume some sort of safety. Even if I do get it working, you're not going to find out probably the answer why the thermistor makes it work. But I think the comments section will clear that up quite quickly. So while I'm cleaning the horrible, oily, messy residue, let's give a shout out to my mate Vince Massive. They are the top level Patreons. The Massive this month are kitdigital.com, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeves.com, DJVG, Pigsy, Anthony Dean, Russ Mellinson, Shigate, Rickard Bergman, Soulreaver555, Shamsa Al Sawadi, Stuart Park, Stephen from the Broken Past on YouTube, Lee Benz, and 360 Picture UK. So a massive thanks to each and every one of you, as always. Oh, hold on a minute. We have another chip here, and here, and here, and here. So there's four of these chips. Yeah, this one feeds this side, this one feeds this side, this one feeds this side, and this one feeds this side here. Okay. So I don't think there's anything to do with BIOS then, is it? The thermistor's something to do with the display. And annoyingly, these are BGA, so I can't actually tell. I can't get it off again. I wouldn't be able to tell you, see, if after that it's you know, if it's also travelling under here from the thermistor. Right, let's get a little bit of hot air on that just to burn off the IPA. In fact, what we could do is let's measure the thermistor and see what it's measuring now and add a little bit of heat to it. So as it's cooling down, it's getting more resistive. So as it heats up, it gets less resistive. So there we go, it's an NTC because the resistance decreases as the temperature increases. Right, now if we zoom in, you can see that horrible goo has now gone. So if we look around here, can you see it's gone now? So let's plug it in just in case. You never know. It's highly unlikely, but you never know. Okay, so it's recognised because it made a noise. There we go. But we still haven't got a backlight on here, so let's turn it on now. Right, so backlight's on. I wonder, have we got anything displaying now? No, it's still blue. Just double check. Yeah, still blue. Okay, So that hasn't made any difference at all. It is interesting because when I look at this, you can actually see like an outline of some kind of liquid on it. So I don't know why, and this has had some reaction with the flux, but I don't think that board would have flux on originally. I'm not quite sure why we have, not sure if that's going to come up in the camera, but you can actually see marks on it in certain areas. Right, so it's not that. I wonder if we were to put our finger on the thermistor to try to add a bit of heat into it, would that make any difference? Or I wonder if we disconnect half the screen, would that make any difference? Yeah, let's turn it off. Let's unplug this and unplug this. Now let's disconnect this one here just to see whether that's going to do anything. Right, that's not going to short. Just trying to narrow it down. No, as far as I can see, the backlights are lit up everywhere. Oh no, it's white this side. Right, so we have it white this side now. Oh, we got half and half. I don't know if you can see that. Yeah, you can. Right, so that's half and half that way. Now I'm going to do the same the other side. Right, so I've got the left hand side connected, right hand side disconnected. So let's plug it back in and see now if we have a white screen over the right hand side. Oh, it's working. Hold on. It's working. Hold on. There you go. Oh no, it's not working. It's it just looks weird. What's that about? Some weird lines around the place. Okay, has that proved anything? No, that hasn't proved anything, has it? So when that one's unplugged, it gives a perfect half white screen, half blue screen. When that one's unplugged, it looks a little bit all over the place. It looks a little bit like a blue broken screen, which is a little bit worrying. I'm going to turn it back on again, just to see. No, I don't think so, because I can see lines slowly moving over here. That's weird. I can see them just slowly growing as it goes along. Just going to unplug it, see if that makes a difference. Oh, voiceover Vince here. I can't believe I've got the right hand side of the monitor on the floor like that, all the way to the monitor, and this is heavy on that top corner. Right, okay. So lucky that didn't smash the screen. I think what we're going to have to do is, let's take the board out again, let's remove the thermistor, see if it starts working. Then if it does, I will still take it further. Maybe we can then prove, is it doing something going down onto here on the end pins? Maybe we can try to get this board out at the bottom and see what it's connected to. But first of all, let's see if this trick works with the thermistor, because if it doesn't, maybe I'm wasting my time even looking at the thermistor. So let's get this board over to the mat again. So we're going to use hot air, and we're just going to move this little thermistor here. I'll tell you what we'll do actually, just quickly, just in case there's the resistors next to it that are not reading properly. Let's see if they're reading open or not. Obviously I don't know what resistance they should be. Okay, so 3,800 ohms. And 3,000 ohms. I don't know what it should be, but it's reading something. So let's get some heat on that and let's move that one just off the pad. I'll leave it on the board so I don't lose it. I'm just going to lift it up off that pad there. Right, 500 degrees Celsius. In fact, I can lower that down a bit. Let's go to 450. And airflow's 150 out of a possible 200. I'm keeping it away from this connector next to it, so I'm angling the heat this way off the board. I'm just going to lift it up onto the other pad. There we go. Now I'm going to let the board cool down, we'll plug it back in, and let's see now if it starts working like all the forums say. Right, actually this will give us an opportunity to test the thermistor and also the pads to see what the pads should be reading. So the pads on their own, it was 3,000 ohms from memory, roughly. So I'm just on the pads. The pads themselves are reading 5,200 ohms. Now remember, this thermistor is probably still warm. See, that's 11,000 ohms. And the temperature's going up because on an NTC, when resistance goes down as temperature goes up, so when temperature goes down, resistance should go up. I'm getting confused. Temperature's going down and that's going down. What? Now it's going up. Doesn't feel very warm. Do you know what? Let me check in case it was something else in circuit. Let's give this a quick little blast. Alright, let's see what it's doing. Yeah, it's increasing as it's cooling, so it is an NTC. Well, I think that thermistor is definitely working. Now let's just make sure that hasn't got a short to ground. No. Now let's plug it in. Right, monitor's plugged in. Let's plug in this. See if we have any life. Right, so it's gone off from here. Let's turn it on here. I think it is going to work. So many people have said it's worked for them. I think it is going to work. Right, here we go. Now, let's see. Oh my word, it's worked. What on earth? Can you see that? There's a symbol here. No signal display port. Because I have to change it. I have to change it to HDMI. So, I hope I don't break this now. Right, let's see. Up you get. So let's see if I can do it via here. Yeah, menus come up. Power off. Don't know if you can see any of this or not. No, you can't. Hold on. Can you see there's a little thing here now? What is it with that thing? Why is removing the thermistor working? Menu source. So let's go to... What's that do? See, it doesn't allow me to go over there. Source. Let's go to HDMI. There you go. Oh my word, wow. What an insane screen. Okay, so clearly the thermistor hack works. Why? Let's shut it down. We need to find out what's going on this bottom board. I think it's something to do with the bottom board, and that's the reason why people, when they're heating the corners with a hairdryer, it starts working. I think it's something down there. I think we're going to have to put the thermistor back, maybe take off this panel here, this white thing, and then you see there might be a capacitor on the board down here which is shorted, and that would be a proper fix rather than doing something which makes it work but we don't know the reason why. But still, that is amazing. I'll have to find out the original post that did that, because obviously what they've done is they've helped a ton of people out. So yeah, I'll see if I can find that on flashed up on screen. Right, I'm just going to shut everything down and let's see if we can get this off here. Well, I hope this doesn't all go terribly wrong now. So first of all, let's unplug this little cable. There goes some remains of the plastic from when I first of all took it apart. And let's undo this little power button here. Now, we have loads of clips. White clips holding this in. I wonder if I take all the top ones off, will the bottom ones follow suit or not? Yes, they will, I think. Wow. There we go. Now, are you going to come off? So off there and there. It looked like they're being held here somewhere. Oh, there we go. Hey, hey, amazing. Okay, so we have 1, 2, 3, 4 boards, and they're all connected up via these little, well, so this is for this side, this is for this side, and then there's a little jumper going between board to board. And these are bent. I wonder if they're straight boards, and the very fact they're being bent, I wonder has a component fractured and then shorted, because these look like, it looks like they're straight and it's been bent round, but there is quite a curve on this monitor. That'd be interesting. So I think what we need to do now is, I think we need to connect it back up again. You've got to be really careful here because these are just glued on. So you can't actually take these boards off. You know, the contacts here are just glued. That's a shame. It's a shame they're not on a little connector. Right, I think it's going to be flare cam time. Also, the boards are not the same. These two boards look the same, but they're mirror images of each other. And these two boards I think look the same. But again, they're mirror images of each other. Right, let's get the flare cam, see if there's any component getting warm. So we're going to have to take this board out again, put the thermistor back into place, because clearly it's working now. And then we might be able to then see if something's getting warm or not. Okay, I'm going to use a little bit of flux, and let's just pop that back into place. So the reason I'm using the flare cam on this is because it may show up something like a shorted capacitor. So rather than me going across every single component and measuring it, if there's abnormal heat somewhere, it could suggest a short, and maybe that's what's knocking this monitor out when the thermistor's in place. And that will show up as a heat spot on the flare cam. Or it might show one chip getting abnormally hot compared to other chips, and it might pinpoint a faulty chip. Okay, thermistor back in place. Let's plug it in, make sure it's not working. And let's turn it on here. Let's see now, have we got the blue screen? Yeah, back to a blue screen again. Okay, flare cam now. Let's see if it will show anything. If it does, of course, I'll bring the camera right in. Right, so I'm just getting reflections off the gold little connectors down here. Right, I can't see anything lighting up there, so there's no shorts there. Ah, this is not good. I was hoping to find maybe a shorted cap. Yeah, so I don't know if the fault's on the board with the thermistor. See, I don't think the thermistor's faulty, or whether the fault's on this bottom board here because it's connected through. Oh, what a shame. I've looked up what these WinBond chips are, these ones, because the thermistor goes to the bottom right on these. These are all the same, but they are slightly different than the ones that are here and here, so the markings are a little bit different. But basically the main 4 that's on the main board is a WinBond 25Q16JV. I'm not sure if it's 1G or IG, but I just typed in that there. And basically it's a serial NOR flash code storage flash memory. And when I look at the pinout for it, the thermistor goes to VCC, which is the power supply. So basically the thermistor is feeding this chip, this chip, this chip, and this chip. So I can understand if the thermistor was broken and was completely open, but what I don't understand is it's when I disconnect it from the board that makes it open that all of a sudden it starts working. So that's what's kind of confusing me, unless the thermistor is somehow bringing it down to ground and by removing it, it then starts working. So let's have a look at that then. Let's see if it is bringing it down to ground. So if I take a ground, let me just make sure that this is a good ground here. Yeah, so that's 2 ohms. Yeah, so I'll take it from here because it's on the actual board. So top of the thermistor is reading, the top of the thermistor is the one that actually goes into the chip. And that is reading 2.6 thousand ohms. Now let's go to the bottom. And it's reading 1.7 thousand ohms. Now let's go to the WinBond chips. It should be the 1.7, which it is, 1.7. Let's go on to this one. 1.69. Let's go on to the one right down here. So VCC, here's the 1.7. So basically it's 1.7 on all those chips. Let me just try the one over here. It is this one. .7. So could that be it? Maybe, because maybe the resistance is so wrong, it's not allowing the voltage through. So I'll tell you what we do. Let's go to voltage. Let's plug this in. I won't bother connecting up my computer because it should have a display even without the computer connected. It should tell you, you should be able to select the input, and it's not doing anything. So let's plug it in now. Let's see what voltage we have on the top of the thermistor, and let's see what voltage we have on the bottom. Then what I'd have to do is I'd have to disconnect I'd have to remove the thermistor, and then, yeah, so with it connected, let's see what's on the WinBond chips, and then I suppose we'd have to disconnect it and then see what's on the WinBond chips. Maybe without it we have 3.3 on the VCC of the WinBond chips, and maybe with it we've only got 1 volt or 1.5 or something because it's being shorted to ground through the thermistor, through the chip. All of this could be related to a faulty chip maybe. I'd have to look up what that chip there is. Let's try this to begin with. Right, so I'm plugged in, and let's get the backlight working. Well, first of all, while it's in standby, let's see what it's doing. So I'm going to go to here, and I'm going to go to the top of the thermistor. Nothing on the top, nothing on the bottom, and let's go to the WinBond. Nothing there. Okay, so when it's in standby there's nothing. Now let's turn it on so we have the backlight livened up. There we go. So all the backlights have now lit up. Let's see what it's doing now. Let's go from here. Got to be careful. I don't want to shock myself, and at the same time I don't want to short the board up. So top of the thermistor we've got 1.2 volts, not very high. Bottom of the thermistor 3.3. So we should have 3.3 then at the WinBonds, which we have 3.3. 3.3. Let's go on to the WinBond down here. 3.3. So is it because we haven't got 3.3 then from the chip? I would have thought the chip was making that voltage, but maybe it's not. I think what we need to do is, because maybe if we had 3.3 at the top, maybe if I was to disconnect that thermistor, we'd have 3.3 at the top. But I've got 3.3 in the win bonds. That doesn't make any sense. I'll get myself even more confused. I'm going to look up what the chip is. I think I need to take off the thermistor again and see what... why has it come on again? I think I need to take off the thermistor again and basically see what's happening on the top. And then maybe if we've got 3.3 at the top, that would suggest what the problem is. Right, I'm looking up this chip here, the big one that the thermistor goes to, and it's RT6949B. But amazingly, it's not on Google. Somebody is selling it on AliExpress, but it doesn't say what it is. And it just says that it's designed for a wide range of applications, from consumer electronics to industrial, blah, blah, blah. But interestingly, if I go to the data sheet here, it's bringing up this one here, which isn't my chip. It's a power management IC for SSD, Rich Tech. But this is a different one. This is RT9996, while mine is RT6949, so completely different. But interestingly, if you look here, basically my thermistor goes round and it goes down to the 5th pin. 1, 2, 3, 4, 5, this one here. And on this diagram here, it's showing as voltage in. I know this isn't my chip, but it is a Rich Tech chip, and it does seem to have the same amount of pins and that same voltage in. So maybe that suggests why it's not working, because there's 3.3 volts at the bottom of the thermistor, and then there's not 3.3 volts at the top. So voltage into this chip is too low. So I think I'm going to take off the thermistor and then see now, are we getting 3.3 volts into this chip? So let's slide the thermistor off, and then we'll take a voltage reading again at the top of the thermistor, which is going into the chip. And that might give us an idea then, the difference between when it's not working and working. Because when it's not working, we know it's 1.2 volts. What voltage will it be when it's working? Okay, I've got it plugged in. Let's turn it on and see if we have that menu screen. Right, obviously there's no computer connected this time. Let's see now. Yeah, there we go. So you can see it's working again. Yeah. Right, let's see what voltage we have now on that top one. I'll read out the voltage, you might not be able to see it. Right, so on the top one of the thermistor, 0.64 of a volt. So we've got half the voltage. Let's go on the bottom one. 3.3. So without it, we've got 0.64 of a volt. That's interesting. Let's turn it off. I want to see what it's reading when it's off. So we have much less voltage. Oh, so if we've got a higher voltage, does it think it's overheating or something because it's 1.2 volts? So whatever that thermistor's connected to, I think it's giving some weird reading that's letting that this thinks it's overheating, and that's why it's not working properly. Just want to see what's happening when we're off here. No voltage. So it was about 1.2 volts with the thermistor in place, and it's 0.6 of a volt when it's not in place. That's interesting. So initially I thought maybe it was a problem down on the, coming down here. But maybe it's not. Maybe it is the actual chip that's at fault. Unless, of course, the thermistor has failed, and under normal room temperature, maybe it should be more open. Do you know what I mean? Maybe it should be, for example, 80,000 ohms. And then as it gets hotter and hotter, maybe then it will go towards 1 ohm, maybe 1,000 ohms, and that may be when it cuts off. So the fact we've got a backlight now, maybe the thermistor's partially working, Maybe if I was to heat that up, I wonder if I was to heat that up, would the blue screen go away completely, if it was in position? Because it could be as simple as a faulty thermistor. Maybe it's not that's masking something else. Maybe the thermistor itself is faulty. Right, I'm going to do a load of testing of just random components with my multimeter, and if I find something, I'll start filming again, because I don't really know where else to take this. Okay, it's not that much later, but I want to film this bit in case this is something. So in one of the comments it mentioned about a voltage divider, and I remember I did a voltage divider before. I can't remember what it was in. I think it might have been this here, and there is a you can work out the resistors. There's like calculators online where you can work them out. So basically what it would be is, let's say, obviously I'm making this up as far as the resistors because I don't know what the resistors would do without going online. But if I had 5 volts here, yeah, and then we had a resistor, and then I've got ground here, yeah, I don't even know what the grounds are. I think it's something like that. If I've got ground here, that's not ground, is it? You know what I mean, ground. Then, if I was to put another resistor here, yeah, and then tap off the middle, depending on what this resistor is and this resistor, this is called a voltage divider, and I might end up with 2 volts here, or 3 volts, or 4.4 volts, or 1.2 volts, depending on what the resistors are. So it's dividing down the 5 volts via the resistors to ground to get you, and you tap off the middle to get your voltage. And one of the comments mentioned about a voltage divider, and looking closely here, this circuit is a voltage divider. So what I'm now wondering is, could one of the resistors be faulty? Because when I started out messing around with electronics, people said to me resistors never really fail, it's always capacitors and stuff. But recently I've had quite a few items where the resistors have failed, where they've kind of gone, instead of being, I don't know, like 500 ohms, they might be in the meg ohms. So they've got a lot more, they've had a lot more resistance on them. Now, the very fact that without this we're getting 0.6 volts and it's working, and with the thermistor we're getting 1.2 volts and it's not working, I'm wondering whether it's out of spec because of the 2 resistors are out of spec. I think the thermistor's working because it changes the resistance when I add heat to it. So maybe one of the 2 resistors has gone and it's not giving us a correct voltage here, possibly. So what I think we should do is zoom in. Well, first of all, let's see if we can measure them. See, well, let me zoom in and show you the circuit. So if we have a look, we already know that this is ground. Yeah, so this is ground here, and it comes along and it goes to the bottom of this resistor. So that's the same as being the bottom of this resistor here. The top of the resistor is here, and that's linked to here, which is then also linked to the top of the thermistor, which is tapped off to bring us voltage into pin 5 of this chip here. You see here, 1, 2, 3, 4, 5. Yeah. Is it that one or that one? 1, 2, 3, 4, 5, 6. Oh, that's pin 6. Okay, maybe that diagram I showed you earlier off the chip isn't relevant then. No, I think it was 5 and 6 and 9. I can't remember, but anyway, it goes into there. And then I think, but I'd need to take these off, I think these 2 here might be linked. Yeah, so I think this is the feed for the voltage, 3.3 volts, and we need to get 0.6 volts out, but we're getting 1.2 volts out. So if I go on continuity, you can hear that ground is going to here. Yeah, then it goes through the resistor. This is all tapped off. This should be the 0.6 volts going here, which then goes all the way over into this chip here. So from the top of the resistors into here. And then I think these 2 are linked, but I don't know if they're linked via here or elsewhere. So I think what we need to do is, I think we need to take all of these off their pads, and then we'll have an idea maybe what's going on. Because I'm hoping now that one of the resistors has failed. Hope I don't lose these now. Right, let's put that there. Okay, I don't want that to blow away. Put that there. I'm wondering, do you know what? Let's just leave the thermistor where it is at the moment. Okay, so I know it's in circuit still, but I just want to see what the thermistor's doing now, bearing in mind the board's still going to be warm. Right, so 10,000 ohms seems about right, I would say. Now, what I'm hoping is one of these resistors is going to be faulty. So let's go to the one on the very left, the tiny. 3.8 thousand ohms. Okay. See, if I had a working board, I could go across them and see. 16,000 ohms. Okay, well, I'm going to get up a voltage divider calculator. I know that 3.3 volts is coming in. I want to see if I put the bottom resistor as 3.8 thousand ohms and that resistor as 16,000 ohms, what we come out with. If we come out with 1.2 volts, then I wonder, do we just, I don't know. Do we need to change one of these to make it equal 0.6 volts? Right, I'm starting to get more hopeful, but I just hope I'm not, I hope this isn't a wild goose chase. So this is ohmslawcalculator.com. And basically, you can see here we have resistor 1, so this is negative, so this is going to be the ground. So this is going to be 3.88 on mine. And then resistor, oh no, so R1 is, I've typed it in wrong. Hold on. Well, I'll do it live now. So this is 16,000 ohms. I mean, 16,000 ohms sounds right. 3.88 doesn't. It just seems a bit weird. So let's put that in right. So basically, resistor 2 is the one that's actually this one here. So let me change this around a little bit. So resistor 2 is 3,880 ohms, and resistance 1 is 16,000 ohms. And let's get rid of that. So now calculate. So it should be 0.6. So it's correct, it should be 0.6. Oh, so let's change this now to 16,000 ohms just to see if they were both the same and what that would actually mean. 1.65. So basically we want it to be 0.6, so that voltage divider is working. It should be 0.6. So why is it not 0.6? It's going to be something to do with that chip, I bet. Because if we were to... Yeah, hence the reason when we take that out, it becomes 0.6. No, but it could still be out. It's 0.6 when it's working, but we're not taking into account the 10,000 ohms, which is across, because we have 10,000 ohms across the whole thing, don't we? We have 10,000 ohms across the whole thing, so how does that impact it? How would I work that out? Because then from here, we've then from the source up here got, hold on, where have we got to 10,000 ohms to? Yeah, the 10,000 ohms is also tapped into here from the supply. So we've also got 10k here from the voltage thing. So how am I going to work that out then? So the resistors could well be faulty, couldn't they? Oh, I really don't know if I'm going down a path that is incorrect, but basically a voltage divider thermistor circuit is an electronic circuit where a thermistor is used as one of the resistors in a voltage divider. And it also says, meaning that the voltage across the thermistor changes based on its resistance, which in turn is directly affected by the temperature, allowing for a way to measure temperature by reading the voltage output from the divider circuit. So the voltage will change depending on the heat in the thermistor. That makes sense, but remember, we've got three things here, but it does say that that it can have a, it's an NTC. To ensure accurate temperature readings, the circuit may need calibration using a known reference temperature. So I thought I read somewhere that it might need another reference, and I'm wondering, there's two vias down here. Remember I said I don't know if they're definitely linked, but maybe that's its own 3.3 volt reference using that resistor. So basically, maybe my, oh hold on, this is starting to make sense. 12, which is my thermistor, plus call that 4 is 16. So this one here is its own reference, I think. So maybe that's how it knows the difference in temperature on the thermistor, because it's taken a reference off the 16 one. Which is saying then that nothing's faulty here. Unless, of course, the thermistor itself is faulty, because as it heats up, the resistance is going to go down. So right now, at complete room temperature, it's 12 volts. Sorry, 12,000 ohms. But if I was to put my finger on, that's going to start dropping, isn't it? And if it starts dropping, my voltage is going to change. So 1 second now. Let's pretend now, so let's take this out, and that's its own reference to this one here. And now my voltage divider using the thermistor is going to be, for example, well, we know what it is 3.3 volts here. Then it goes down. This is my thermistor here, TH. And then it goes down to my, call it a 4K resistor. And then that goes down to ground. Yeah, and then we're taking the voltage off here, which ideally we want it to be 0.6 volts because we know it works at that. But we're getting 1.2 volts when this is in circuit. Yeah, so now let's find out using our calculator what ohms this is going to be to get 1.2 volts here, and then we'll have something, because we know that 16 volts and 16,000 ohms and 4,000 ohms does equal 0.6 volts. Let's do that again. I feel like I'm getting somewhere. Right, so let's go back to the voltage divider circuit and let's clear everything apart from that there. So if resistance 1, let's just double check this, is 16,000 ohms, which we know it is in our circuit, and let's just call this 4,000 ohms because I think that sounds more correct. 4,000 ohms. So let's get rid of that. Calculate. 3.3. 0.6. So we know the reference is okay. So ideally, we want our thermistor to be 16,000 ohms, not 12,000 ohms. So let's now change this one here to 12,000. And let's see what the voltage is going to be. 0.8. So we can see that the lower in the resistance here, the higher the voltage here. And as we know, resistance goes down as temp goes up. So if I was to heat this up, we should have a higher and higher voltage. So maybe when this is in the board and these things are getting hot, this thermistor is getting more and more hot. So let's go here and let's see what it's reading now. Right, so it's 12,000 ohms. I'm going to put my hand on it to heat it up. And you can see it's dropping. So maybe the thermistor has gone out of spec. But I wonder if we can adjust it by adjusting our other resistor, the 4,000 ohm resistor. I mean, that's just my finger now. So if that was to go to 10 here from just my finger, and remember it's going to be hotter when it's actually properly powered, 10,000 ohms. Let's see what it is now. We've gone up to 0.9. So let's add just a tiny little bit of heat as if it was in the board. I'm not going to add much heat. Remember, we could definitely see on the flare cam that these were warming up. That is going to have an effect on things. Right, let's just see what that is now. We've now gone to 5,000 ohms. So if we were to do 5,000 ohms here, let's delete that. ,5,000 ohms. Calculate. There you go, 1.4. And we know in the board that it's 1.2. So I'll tell you what we'll do is, let's go to this one and now do 1.2 here and see what has to change, because that's what we know is happening. 1.2, hold on, so let's leave this one blank and let's do this as 1.2. 7,000 ohms. And at the beginning when I measured it in circuit, wasn't it 7,000 ohms or 6,000 ohms? I think it was. Okay, so let's take it now that that's 7,000 ohms. What would we have to change this one to get this back to 0.6? Because maybe I can leave the thermistor in there because it is working, and maybe I can change the rest of the circuit to match that. I'll probably get stated in the comment section, but please do not copy what you see in these videos. Maybe this will make the thing go up on fire, but at least the comment section will be interesting to see if what I've done is a workaround, or maybe by using these calculations, some clever person will be able to work out what thermistor we do actually need, because it looks like we're going to need a... Hold on, sorry. If we want this to be 0.6, well, let's see what we're going to need. So let's put this as 0.6. Well, we need it to be a 16. It needs to be 16,000, doesn't it? So 0.6, calculate 18,000. So I think we need a thermistor, which is 18,000 ohms at normal room temperature. I wonder, can you buy them? Anyway, let me just put this back to 6,000 ohms. And calculate. Right, so that's going to be that. So I want that to be 0.2. So let's see what I can change this to. If I put this to 8,000 ohms, what happens? 1.88, so that's gone the wrong way. So let's put this down to 1,000 ohms. 0.4, that's too little. Let's go to 2,000 ohms. 0.8, I want it to be 0.6. Let's go to 1.5. I know this is painful for some of you, bear with me. 0.66. I think I am going to take out this edge one, but then what's going to happen? Hold on, what's going to happen to my reference? So let me just write down 1.5 for the moment. If I have then this one at, because we know that this one is 16,000. Let me just double check that. This one's 16,000. Would I have to change that as well? That's 16,000. I'm going to have to change that as well, aren't I? Because those two equal 0.6. So bear with me a second. I know I'm going all over the place. So if that was going to be 16,000, what does that equal my voltage at? 0.2, so it's way too low. So let's do this one to 8,000. It's going to have to be 6,000 again, isn't it, to match the... I wonder, am I going to set everything... Is everything just going to break? I don't think Brian would be too upset. So really I need this one to be 6,000. So I think I need to change my resistors to a 6,000 ohm one and a 1,500 ohm one. Do you know what? I'm going to give it a go. Right, I've been having a look around at the resistors that I've got that look to be, I think, the same size. They're absolutely tiny. Look at the size of them. And obviously I haven't got a huge amount of them. So I haven't got a 6,000 or a 1,500 ohms, but I have got a 10,000 and a 2,200 ohms. Now, for the reference, 10,000 up top, which will be the middle one, and 2,200 on the edge will be 0.595, so a little bit less than the 0.6 that it works on. Now, if I was to clear that, and let's say if I start here when the thermistor is cold at 12,000, then if I go to calculate, can you see I've got 0.5 volts? It might be enough to make it work, and then as it warms up, it will become more like the same as not having the thermistor in, the 0.6 volts. So if I was to go to 8,000 ohms, which is what it should be when it starts warming up more, and go to calculate, can you see it's gone to 0.7? And then if I was to go to 7,000 ohms, it goes to 0.78, all of which may work. It's quite a long way away from the 1.2. So let's do it. Let's just see on here if these are measuring what they say they're measuring. So this should be 2.2 thousand ohms. So 2,200 ohms. There you go, 2,200 ohms, excellent, or 2.2. And this should be 10,000 ohms. There you go, 9.99K. Yeah. So let's pop them in. I'll say it one more time, do not copy what you see in this video. Loads of people have taken the thermistor out and they're saying it's worked just fine, but clearly the thermistor is there for a reason. I'm thinking if I can do some workaround where I keep the thermistor there, if it got to a condition where it was getting hotter and hotter and hotter and hotter and hotter, then it should still, I'm thinking, recognize that it's getting hotter and hotter. The voltage will go up and maybe that's the signal in the chip here to turn itself off. But please don't copy what you see in my videos. Read the comment section. There's loads of people who watch my videos that are really knowledgeable and they will let you know whether what I've done is safe or not safe, whether it's safer without the thermistor. So take it purely for entertainment.
Okay, apologies, the video is really starting to drag. It's just there was quite a lot of content and I don't really want to cut out massive bits because then you're not following my thought process and it's going to be harder for people to kind of advise what's correct or incorrect if I cut out massive bits of it. Hopefully it's not too boring. So I'm just going to quickly put these resistors in. I'm keeping the old resistors because and if the comment section say, Vince, you just need to buy a 16,000 ohm thermistor and put the old resistors back in, that's exactly what I will do before giving it to Brian. But I'm putting the 2,200 ohm resistor on the left hand side and I'm putting the 10,000 ohm resistor in the middle, and then we'll see if it works. Right, I've got to keep my voice down because it is 1 o'clock here in the morning and people are asleep, so even if it does work I can't go crazy. Right, I am actually very nervous because the thing is, if I end up blowing this up, then everybody's going to say, what an idiot, I should have just taken out the thermistor. But I'm trying to prove what the fault is because on the internet there's loads of people talking about this and I think it'd be nice to actually prove what the fault is. But even what I'm doing now, I don't think it's proven it unless one of the resistors went out of spec, or maybe the resistor or the thermistor's gone out of spec and then I'm messing with the resistors to try to make the thermistor in spec. I don't know, but yeah, I'm used to getting abuse on YouTube, so it's not gonna matter too much. Right, I hope it doesn't go on fire now or break something, because that would be disappointing. But honestly, I don't think Brian will be too upset. Right, let's plug it in and see what's going to happen. Right, let's plug it into the wall. Right, so far we have a blue light. Nothing's gone on flames yet. Here we go. Please, please, please work. Slightly apprehensive. Just is it backlights on? What do you think? Yes or no? Please, please, please give me something. Please give me something. Oh my word. We've got it. We've got it. We've got it. We've got it. Amazing. Right, let's see what voltage we have. It could still go up in flames. Let's see what voltage we have now on the thermistor to see is it close to 0.6. So be careful. Put that there. Hopefully you can see that. I'm going to go here and I'm going to go on top of the thermistor. 1 volt. Interesting, we've got 1 volt. Let me go on top of the second resistor. I'm going to do 10,000 ohm one. 1 volt. 1.04. Is that exactly the same? 1.04. I don't know what to say. Maybe that is fine. Maybe when it heats up, it's going to start failing. Let's have one more look. Alright, yeah, it's over here now. You can't see it, but it's over this way. Well, let's see if it turns off. Yeah, I think what I'm going to do is put it back together and leave it down to the comment section, but surely having the thermistor in there is going to be better than nothing.
1 volt sounds like it might well be just fine. Maybe at 0.6 volts it's only just working, but maybe at 1 volt it's more comfortable. Who knows? I don't know what it should be, you know, on a proper working one. I quite like that little workaround. I'm going to be really interested to see what the comment section say about this, because I'm really curious as to is the fault on this board here, or a lot of people saying the fault is on one of these boards at the bottom, and by disconnecting the thermistor you're just doing a workaround. So what I'm doing is still a kind of workaround, but the thermistor is in place still. But I don't know if I was to heat that thermistor up whether it would stop working. I don't even know what the thermistor's there for. Anyway, I'm going to put it all back together. Well, putting it together is quite a satisfying affair because you're dealing with clips, and it's always nice to put clips back together. So it all goes back very, very nicely. So let's connect up the little laptop and now see if we have a picture with the thermistor in place. All right, here goes. I'm not plugged into the computer yet. Let's turn the monitor on first of all. Let's see if the menu still works. Please turn on. Result. HDMI up here, and let's just see if I press this in. Does it bring up? Yes, it does. Yeah, so that's the menu, power off, source, and I don't know what that thing does. Right, okay, so now let's plug this in and see if my laptop displays up here. It's made the noise. Result, here it is. Amazing. Oh, there we go. Oh, whoa, that is insane. And my mouse is working. Oh, that is so good. Wow. Right, let me go to YouTube. Well, I have to say, it looks absolutely insane. It really, really does. I wouldn't mind it for myself, if I'm honest with you. I might ask Brian if he wants to sell it. I think it's unbelievable. I wouldn't pay £2,000 for it. But yeah, I really, really like it. Okay, what I'm going to do is I'm just going to call it a day now because it's late. I want to actually leave this on for a little bit tomorrow. Maybe mess around with the brightness and stuff.
Right, it's the next day now. Look at it going through its rainbow effect there. Now, I haven't been putting it through its paces because I can't actually do the refresh rate to what this monitor can actually do. So all I've been doing is putting the brightness up, listening via the headphone jack to make sure that you can adjust the volume, and basically just looking at the image, and as far as I can see, it's working just fine. So I love this thing. I think it looks absolutely amazing. I actually priced up them on CEX to see how much they might be. And yeah, they kind of range, basically depending on condition, between £500 up to £800, or £407 up to £800. So not too bad. But in reality, if I actually had this, would I have the space for it? I'm not sure. I mean, I sit very close to my monitor, and if I'm here, I think I'm going to get a sore neck going left to right all the time, or eye strain going left to right. I love it, but in reality, I think the novelty may wear off. So yeah, I'm not going to get one, but if Brian didn't want this, I think I'd be happy to pay £200 or £300 maybe for it. But I'm not too sure if after a bit of time the size would actually get on my nerves. Rather than being an asset to me, it might become a hindrance, a bit like the Rolls-Royce was. So yeah, lots of questions for the comment section down below. I suppose the first one is, when the temperature goes up, so as this gets hotter and hotter, the voltage is going to go up. So does that mean that chip that I can't find a data sheet for, is it going to go into some sort of over voltage protection, or will it just burn out? So that's one question. And secondly, what do you think the problem was? Do you think the problem was that one of the resistors went out of spec, or do you think the actual thermistor has gone out of spec, or do you think it could be both, the thermistor and one of the resistors? And lastly, I looked up how thermistors can fail, and it said online that a thermistor is considered to fail when its resistance becomes significantly different from its expected value, which usually means a decrease in resistance as the temperature increases, indicating a failure due to lower resistance than expected for a given temperature. So if we have lower resistance than expected, we're going to have higher voltage, which is what we had here, 1.2 volts rather than 0.6 volts when the thermistor is not in place. Now it seems to be about 1 volt. So maybe as it gets hotter and hotter, when it gets to 1.2, it will
fail, but maybe what we see is borderline failing. Maybe if it went to 1.4 volts, it might shut off completely. What we may see there is the chip not operating properly, but it might be on the boundaries. I don't know. I really haven't got a clue. So basically, what was it originally? So basically, originally it was this 3.3 volts coming in, 6,000 ohms on the thermistor roughly, and then this one was roughly 4,000 ohms, which is then going to equal 1.32 volts, which is no good. And then basically, when it was brand new and working, I presume the thermistor is going to be around about 10,000 ohms, 4,000 ohms for that resistor, and then that's going to equal 0.9 volts out. So we know that's going to work, that's not going to work. What I've done is the thermistor now I think is reading about 6,000 ohms when it's in the circuit and slightly warm, and I've put in a 2,200 ohm resistor there, which is now equaling 0.88 volts. So yeah, is that correct? What do you think? What do you think's failed here? Please add it to the comment section. You're going to help a ton of people out. Basically, there's no way I would have been able to fix this without Google. So all the people on Reddit that commented, then you helped me out massively, and clearly you're helping other people out massively as well. And maybe now this video via the comment section will help out other people in the future. So please don't just blindly copy me, because I don't know what I'm doing, but hopefully the comment section will clear up anything that's not made clear or dangerous in the video. Fingers crossed. So a massive thanks to Brian for letting me work on this. I thoroughly enjoyed this one here, and hopefully it will make for an interesting video. If it has, give it a big thumbs up, and I will see you all very soon. Thank you so much for watching.
Rusty red on her shoulder, I was cleaning her shoe when it clicked on the trot over in the bright morning dew. We brushed and we braided dandelions and chewed. It was a mutual arrangement we both saw into. Can she walk in the fire? Can she run in the rain? Can she make it up the mountainside? Can she make it down again? I have often wondered if she'll go and jump the fence. Will she keep on moving onward or stay in what could have been? Broke my arm in December, we were running for the thrill. You turned